Open your books to page 385. We are in lesson 26.1 today, so we're starting a new activity, and it's all about factoring. And factoring is the opposite of multiplication, or we're undoing multiplication. We just don't call it like dividing. So what we need to do today is we're learning about the greatest common factor, which is GCF. So we need to identify the GCF of the terms in a polynomial, and then we need to factor out that GCF from the polynomial. So we're going to have bookwork and a note sheet today. But if we are looking, we have Factor Steel Buildings, which is a company that manufactures prefabricated metal buildings that are customizable. All buildings come in a square or rectangular design. Most office buildings have an entrance area or a great room, large offices, and cubicles. The diagram below shows the front face of one of their designs. The distance C represents space available for large offices, and P represents the space available for the great room. So if we're looking at the figure or the picture, C right here is the offices, P is the great room. Determine how much material is needed to cover the front wall of the building. We are going to represent the total area as a product. So this question is still multiplying. Product means to multiply of a monomial, which is one single term, and a binomial, which remember is two terms. So how would we find the area? Well, we need to multiply side times side, or length times width. Okay, and so my single term or my monomial is going to be this 10, that side, and the binomial is going to be this entire side, so it's C and P, or C plus P. Represent the same area from question 1 as a sum of two monomials. So if you're looking, the area of this part of the office is 10 times C, which is 10C. That's a monomial. Plus the area of this room is 10 times P, so that is 10P. So we're going to add 10P with 10C. Now, how could we show that question 1 and question 2 are equal? Well, what do we call this? What's that property that we've been using? It starts with a D. It's the distributive property. Question 4 says that Factor Steel Buildings inputs the length of the large office space C into an expression that gives the area of the entire office space. So here I see a trinomial. We need to determine the greatest common factor of the terms in this polynomial. So here's the deal. The greatest common factor is the greatest monomial, or the greatest term, or the largest, biggest number that goes into each of these terms without a remainder, without anything left over. So I don't want a fraction, I don't want a decimal. I just want a whole number. So what I need to do is I need to look at my coefficients, my numbers here. So I have a 6, I have a 12, and we have a negative 9. And we want to think of the largest number that 6, 12, and negative 9 are divisible by. It would be 3. Right? 3 goes into 6, 12, and 9 evenly or perfectly without a remainder. Okay, now if I'm looking at the variables, the letters, do they all share the same letter? No, because this is a c squared, this has a c, -9 has nothing, so it's just 3. They do not share any of the same variables here. So, on the top of page 386, we see example A. And the My Notes section of your book says, to factor a number or an expression means to write the number or the expression as a product of its factors. A factor is any of the numbers or symbols that when multiplied together form a product. For example, 2 and x are factors of 2x because when we multiply 2 and x, we get 2x. So let's walk through example A and then we'll fill in some notes. It says determine the GCF, the greatest common factor of all the terms in the polynomial. So if I'm looking here, I want to look at my coefficients or my numbers first. So 6, 2, and 8. We can ignore the negative sign for right now. And we need to think, what is the largest number that divides into all of these? Well, 2 is the smallest number up here, so let's start with 2. Is 6 divisible by 2? Is 8 divisible by 2? Yes. So my GCF, the number, would probably be 2. And if I'm looking, do they all share the same variable? Yes, this has x cubed, x squared, and x. Well, I want what they all have in common. And together, they all only have one x in common, right? 8 only has one x, 2 has 2 of them, and 6 has 3 of them, but they only share one in common. So my GCF, my greatest common factor here, they all share is 2x. That's the biggest number and the most amount of letters, okay? So on our note sheet, let's fill in that GCF stands for greatest common factor. So sometimes I write notes off to the side here just to remind myself. We need to look at questions 1. So I see 36 and 54. And we're looking for the largest number or the greatest number or the highest number, the biggest number that goes into or is a factor of 36 and 54. So think about like your multiplication chart or your multiplication facts. They're both divisible by 2, but it might not be the largest, so keep going. Are they both divisible by 3, 4, 6, 8? This is like guessing and checking, which is what we had to do when we were simplifying radicals. So the largest number that they're both divisible by is 18. Okay, so for question 2, let's look and think, what is the largest common factor of 15 and 12. What's the biggest number that those are both divisible by? It would be 3. And then, do they both have the same variable? Yes, they both have an x. Okay, so when we're looking at how many x's they share or what they have in common, we want to find the smallest or the lowest exponent on that common variable or letter. So I have a 7 here and I have a 4. So what they have in common is 4 x's. So 3x to the 4th power is the GCF here. So look at 32 and 40. I know they're both divisible by 2. Are they both divisible by 4, 6, 8? What's the largest number? This would be 8. Okay, and now let's look at the variables. So I have an a squared and an a cubed. So at most, they have a squared in common because that's the smaller of the two. Now let's look at the b's. This has 1b and this has b squared. So together, they have in common 1b because that's the smaller of numbers of 1 and 2. Smallest exponent on the variable. Okay, look at question 4. So 14 and 21. It's the largest number that divides evenly into both of those. So try 2, 3, 4, 5, etc. You want the biggest one. So what you could do here is you could start at 14 because 14 is the smaller of the two numbers and do 21 divided by 14. That doesn't work. Then work backwards and go down to 13, 12, 11, 10. Work largest to smallest. And we get 7. I see they both have an m. So 5 and 4, I need to pick the smaller one. So 4 m's in common. And then if I'm looking at the n's, I have n cubed and n squared. So they share n squared because that's the smallest exponent. So this is just us identifying the greatest common factor as practice. Okay, we're going to practice again how to find it here using these 3 questions, and then we're actually going to learn how to pull it out or factor it out. So look at 22 and 33. Those are 2 terms. Start with 22 and see if that works, and if not, work backwards. Go down to 21, 20, etc. The biggest number would be 11 here, and they do not share any letters or variables, so that's all we can pull out. So I want you to pause the video and try questions 6 and 7. You can do it. So the largest number is 2. I started at 10 and worked down. And then I have a y4, a y squared, and a y, so it's just a y. I notice that they both have x's. The lowest or smallest exponent is 3, so x cubed is what they share. Y squared and y to the 4th power, the smallest one is 2, so y squared is what they have in common, or what they share. Okay, let's actually learn how to pull it out now. So I'm going to go back to this example here in our book, and we're going to learn how to factor it out or pull it out. So I'm going to skip this middle step here, and I'm going to go to this bottom row here. So what we need to do is basically we're dividing our numbers. Okay, so when I'm factoring something out, we said that our GCF here is 2x. So what I need to do is pull out my 2x out in front. So we're basically undoing the distributive properties, the opposite. So when I pull out that 2x, we need to take and divide our numbers. So 6 divided by 2 is 3. So that's where this 3 comes from. Then we're also going to divide our variables or our letters, but think about our exponent rules. Okay, when I have x cubed and I'm dividing an x out, this is a fraction, so remember we keep the base, which is x, and we subtract 3 minus 1, and we get 2. So we're left with x squared. So that's where this x squared comes from. So it's 3x squared. So when we're dividing our variables, we actually subtract the exponents. Okay? So then if I'm looking at my next number, I have 2x squared. 2 divided by 2 is 1. So we could write the 1 here. But remember, mathematicians are lazy, so we don't always do it. And then I need to divide x squared divided by x. So subtract 2 minus 1 and we just get 1. So that's where this x comes from, so plus 1x. And then I have a negative 8. So negative 8 divided by 2 gives me negative 4. And then I have x divided by x. Well, 1 minus 1 is x to the 0 power, and we know that's just 1, so we don't write it. X divided by x cancels out. So I'm just left with a negative 4, which is where that comes from. Now, how could we check our work to see if we did this right? We could take this and distribute the 2x back through, and if we did it correctly, we would get this exact answer that we started with. 6x cubed plus 2x squared minus 8x. Don't worry, this is going to get a little bit easier the more we go through problems and examples. Okay, so try these A in your book on page 386. I'm going to help you through these. We are going to find the GCF first, and then I need to factor that out. So let's look at our numbers. I have 36 and a 24. So start at 24 because that's the lower number of the two, and try dividing those by 24. If it doesn't work, then work backwards and go smaller. Try 20, 16, 14. We know it's going to be even numbers. So we get 12. So 12 is my GCF. And then now we actually need to factor that out or pull that out. Okay, so let's think about it this way. 36 divided by 12. You can do that in your head or type in it into your calculator. And we get what? 3. So we're going to put a 3 here. And then keep the y, because I'm not doing anything with it. It's staying right where it's at. And then we need to do negative 24 divided by 12. And we get negative 2. So this right here is my answer. I'm factoring out the 12, and what I'm left with stays inside my parentheses. And now, let me show you. If I multiply these, I get 36y minus 24, which is what we started with, so we know that we have factored out the greatest common factor correctly. Okay? So I just want you to pause the video and try to the best of your ability questions B and C. If you get stuck, that's okay. So we're looking at 4, 6, and 10. And the smallest number is 4. But I know 4 doesn't go into 6 or 10, so that doesn't work. I'm not going to try 3 because it's odd. So let's try 2. 4 divided by 2 works. 6 divided by 2 works. 10 divided by 2 works. That's the greatest common factor. And now let's look at the variables. They all have x's. 5, 3, and 2. So 2 is the smallest. So they all share x squared. They all have an x squared in common. So let's factor that out. So let's put a 2x squared out in front, and then I need parentheses. And if I'm starting with a trinomial here, 3 terms, I'm going to be left with 1, 2, 3 terms inside my parentheses. So remember, we're going to divide our numbers. Not our hashtags. So 4 divided by 2 is 2. And then when we're dividing my exponents, it's basically a subtraction problem. So 5 minus 2 is 3, so it would be x cubed. Put your negative or your minus sign in there. 6 divided by 2 is 3. And this time we have an x cubed, and we're taking away an x squared, so subtract it. 2 minus 3 is 1. You can put the 1 there, you don't have to. And I have an addition sign. Divide my numbers, so 10 divided by 2 is 5. And then if I subtract 2 minus 2, we get 0, so it's gone. I'm pulling out that entire x squared. All right, I'm going to check my work just so you see. 2 times 2 is 4. X, 2 plus 3 is 5. Minus 2 times 3 is 6. X, 2 plus 1 is 3. 2x squared times 5 is 10x squared. And we got exactly what we started with right here. So we did it correctly. But this is my answer to the question. What's in red is just me checking my work. I see 15, 10, and 5. 5 is the smallest of those numbers, so I'm going to start there. Is 15 divisible by 5? Yes. Is 10 divisible by 5? Yes. So my GCF here would be 5. And they do all not share a t, so I'm only taking out a 5 here, which means I need to leave my t's alone. Okay, so divide our numbers. 15 divided by 5 is 3. Leave the t squared. 10 divided by 5 is 2. Leave the t. And 5 divided by 5 is just 1. And again, if I use the distributive property that we learned before, I would get exactly what I started with. So let's do the questions on our note sheet. 8 through 13. I'm going to get you started with some of these. Remember, we're looking for the largest number here. We just kind of have to guess and check and use your factor chart and what you know about odds and evens and stuff like that. So 30, 15, and 10. 10 is the smallest, but I know it doesn't go into 15, so that's not going to work. Okay, and now think, they're not all even, so those numbers aren't going to work. So think about your multiples. So 5 works, right? 5 goes into 10, 15, and 30. And then I have 8 x's, 5 x's, and only 2 x's. So x squared, that's the smallest. They all have it in common or share it. So we're going to divide out our numbers. 30 divided by 5 is 6. I'm going to also divide my x's, but that means I need to subtract. So what do you get when you subtract 8 minus 2? 6. Then negative 15 divided by 5 is 3. X, 5 minus 2 is 3. 10, divided by 5 is 2. And then x squared divided by x squared cancels each other out. Number 9, I have 6, 18, and 36. So of these three numbers, 6 is the smallest. So that's where I'm going to start. And I know that 18 is divisible by 6, and 36 is also divisible by 6. Okay, and then let's look at the a's. I have a cubed, a fourth, and a fifth power. So cubed is the smallest. And I have a b cubed, squared, and to the fifth power, and squared is the smallest. So this is my GCF, 6a cubed b squared. 6 divided by 6 is 1, so that's gone. A cubed divided by a cubed is gone. B 3 minus 2 is just 1. 18 divided by 6 is 3. 4 minus 3 is 1, so you can put the 1s there if you want. B squared divided by b squared is gone. 36 divided by 6 is 6. A 5 minus 3 is 2. B 5 minus 2 is 3. End your parentheses. So pause the video right now. I want you to try 10 through 13. And then you can check your answers when you're done. So they have a 7 in common, that's the biggest number, and a y cubed. 21 divided by 7 is 3. Y 6 minus 3 is 3. And then look, 7y cubed and 7y cubed are the exact same. So when we divide these, we're left with 7 divided by 7 is 1. Y cubed divided by y cubed is 1, and 1 times 1 is 1. So you have to put a 1 here as your placeholder. Remember, if I start with 2 terms, I need 2 terms inside my parentheses. Because then when I distribute this, we get the negative 7y cubed term that we need. Okay, so for question 11, I have 4 terms. So when I factor something out, I need 4 terms still inside my parentheses. So this is a 1, and this is a 1, and I have a 3 and a 5. So they don't really share any numbers besides 1, so I'm not going to pull out a number. Let's just pull out a letter. So I have x to the 9th, 6th, 4th, and squared. So x squared would be what they all have in common. So x, 9 minus 2 is 7. I need to leave the 3 because I'm not dividing it out with anything. X, 6 minus 2 is 4. Leave the 5. X, 4 minus 2 is 2. Plus, and then x squared divided by x squared is 1. So I started with 4 terms. I need 4 terms inside my parentheses. And again, you can always distribute back through to check your work. 16 is the smaller of the 2 numbers, so that's where I started, and it works because 48 divided by 16 is 3. Leave the x. 16 divided by 16 is 1. I started with 4 because that's the smaller of the three numbers, and it works. It's the greatest common factor. And because 8 and 16 are divisible by 4. They don't all share a w or a y, but this has x to the 4th, x squared, and x. So they share an x. 8 divided by 4 is 2. X. 4 minus 1 is 3. 16 divided by 4 is 4. X. Leave the w. Plus 4x divided by 4x is 1. You can write the 1 if you want. You don't have to. And then don't forget the y that's there. So this is where we're going to stop today, the front side of our notes, and we're going to stop in the book.